Hello students. Hello students, welcome you all in second lecture of chapter electrostatic potential and capacitance. In first lecture we discussed about electrostatic potentials, and potential means ability of the body to do some work. The conditions are yes, viparit situation, the force is conservative, and kinetic energy of the charged particle which we are taken from infinity to a point that is equal to 0. And in last lecture we discussed about electrostatic potential for a positive charge, that is kq by r, and your homework is calculate the electrostatic potential for negative charge, and I think you got this answer, minus kq by r. So in this lecture we are going to study, we have discussed first of all 2-3 numericals, and then we discussed about electrostatic potential due to a ring having charge. Then we discussed about electrostatic potential due to electric dipole. Okay, so let's begin. So the first question is, suppose you have two charges plus q and plus 4q. Here you have these two charges and you have to find out a point where net potential will be 0. Okay, take this negative for your simplicity first. Take simple example. This is positive charge and this is negative charge, and they are placed at a distance r. So you have to find out where the net potential between due to these two is equal to 0. So let's take this is a point at a distance a. So this point must be r minus a. Yes, this is r minus a. Okay, now potential due to plus q charge is kq by a, and it is positive because of this positive charge. Now potential due to minus 4q charge, potential due to minus 4q charge, it's negative minus k. What is this q? Q represents source charge, and source charge is 4q by r minus a. This is total potential. This is the potential. Now at this point O, we are assuming net potential will be 0, as we assume net potential is 0 at point O. And I earlier told you that potential is a scalar quantity. It means potential due to q plus potential due to minus 4q is equal to 0. Then we get a net potential is equal to 0. So we just simply add them because this is a scalar quantity. So it becomes kq by a minus k minus k 4q by r minus a is equal to 0. Now take common kq, and it is 1 by a minus 4 by r minus a is equal to 0, and now just solve it. Okay, so kq is equal to kq gets 0 if we take kq in that side, because right hand side is 0. So it becomes r minus a by taking LCM minus 4a by r a minus a square. I just multiply it by taking LCM. These two are multiplied and these two are cross multiplied. Okay, now r minus, it becomes r minus 5a is equal to 0, because this part over goes that side, because of that 0 becomes 0. So r is equal to 5a. Okay, so a is equal to r by 5. So this is the point where net potential will be 0. Okay, I just repeat it for you. This is potential for q charge and this is potential for minus 4q charge, because this is negative, source charge is negative, this is positive, source charge is positive. Now we assume a net potential is 0 at point O. It means potential due to first and potential due to second, both sum of both is equal to 0. So potential due to first kq by a minus potential due to second minus k 4q by r minus a. Just add them After we can take common kq, it becomes 0 over that side. Now taking LCM, r minus a minus 4a divided by a into r, or a square minus a square. This part also becomes 0 by cross multiplying. Okay, so it becomes r minus 5a is equal to 0. So 5a goes that side, it becomes plus, so a is equal to r by 5. So this, like this you can solve it. One more question for you. Suppose it is plus q charge and it is minus 3q charge. Okay, now you have to find out net potential inside as well as outside. Okay, inside I told you. Okay, let me tell you outside for the same question. Then this is for your homework. Erase. Should I erase better? Okay. Now this is for your homework. Okay, I'm just explaining you the same question. This is plus q and this is minus 4q, and they are separated by a distance r. And now suppose at this point O, the net potential will be 0. This distance suppose is x. From the center between them, the net potential will be, this distance is measured from the center. So potential due to plus q is equal to, what is this beta? It is r by 2 and it is r by 2. So it becomes or you can say, you can make it more easy, that you take the distance from this point. It's more easy for you. Suppose this distance is x. Okay, now it's more easy. For this it is x, or for this it is r plus x. It's more easy for your calculation. So for potential due to q, it's k q by r plus x. And potential due to minus 4q, it becomes k 4q minus sign because of negative charge divided by distance is x. Now again the same thing, net potential will be 0. V net is equal to 0. So V1 plus V2 is equal to 0. What is V1? It's k q by r plus x minus, because of this, k 4q by x is equal to 0. So it becomes kq divided by 1 by r plus x minus 4 by x is equal to 0. So this kq again becomes 0 if we take that side. So it becomes x minus 4r plus x, we just cross multiply, x minus 4r minus 4x by r plus x into x is equal to 0. So this part becomes 0. So here we get x minus 4x minus 4r minus 3x is equal to 0. So we can relate from this, from r and x. So minus 4r is equal to plus 3x. So x is equal to minus 4 by 3r. Okay. So this is our answer. Negative means in this direction, not in this direction. Okay. Now next beta, potential. Okay, this is the question for you. You have to find out net potential is equal to 0 for both outside as well inside. This is the question for you guys. Okay, you have to solve it. Okay, now next, potential due to a ring. Potential due to a ring. So in this case, initially we are having a ring, and that ring is uniformly distributed with the charge, and we have to find out potential at any point P due to that ring. Suppose this is the ring we have, and this ring is uniformly distribution of charge. Don't confuse beta, every time I take positive just for simplicity, because it's easy to calculate with positive. But I think now it's clear to you, if here we have negative charge, then potential become negative. So the radius of this ring is R, and we have to find out potential at any point P, which is at a distance of x from the center of the this ring. Center of this ring, potential due to a ring. This is your next topic. So now for this, obviously beta, potential or electrostatic things, electrostatic potential is calculated for point charge. So for that we are taking a point charge over here, a small charge here, that is dq charge. Okay, and we just find out potential due to this over here. So what is this distance? This is r square plus x square. Because for potential, the formula is V is equal to K Q by R. What is this Q? Source charge. What is this R? Separation between source charge and point. So this distance is root of r square plus x square. Okay. Now what is potential? It's dV, because we are taking a small charge, so potential will be small. It is equal to K dq by r square plus x square under the root. This is our potential. Now we have to integrate it. Okay. Similarly, we can take a small length element over here, a small length element over here, a small charge element, lots of charge element we are taken, and then we just integrate it. So it becomes K by r square plus x square under the root into dq is equal to dv for ring. Because our potential is a scalar quantity, so it's not necessary to make components over here and then solve. So we can directly solve it. For ring, that it becomes kq. If q is the total charge, q is total charge on ring. Okay, so it is kq by root of r square plus x square. So this is the potential due to a ring. Potential due to a ring. We can do a special case if this x is approximately equal to 0. If this x is equal to 0, if x is equal to 0, then it is kq by r. It is kq by r, because this will be 0 and r square and square root cancel, so we get only r. So note it down. Okay. Now the next thing which we are doing, that is potential due to a dipole. I just repeat all the things. We are taking a small charge element, then we calculate potential for that. That is dV is equal to K dq by r square plus x square under the root. But we need to find out the total ring. So for that we integrate. Okay, integrate for ring. For total potential, because it's a scalar quantity, so directly we just add it. So it becomes dV. That becomes V for ring, for ring. Okay, and it is K by root of r square plus x square. This is a constant part, we can take it common. So dq becomes q, where what is q? Total charge on ring. So our answer is kq by root of r square plus x square. Okay, this is a special case. If x is equal to 0, then it is kq by r. Now potential due to electric dipole. Okay.